Hello again. Let's look at this example. D by dx of the cosine of the square root of x. We do the chain rule, and we let u equal the square root of x, so we replace the square root of x with u. So we get d by dx of the cosine of u d by du of the cosine of u times d by dx of the square root of x. Again, we do d by dx of u in terms of x. This is the u term here. Now, the spacing here is quite bad. Let me move that down. And let me do one other thing in terms of spacing. Let me do that. I want to make this easy to read. So let's do that. So again, we had this guy right here times this guy right here. Now, d by du of the cosine of u, that's just the negative sine of u. And then times d by dx of x to the half power. But now we know but let's go over here. Now we know d by dx of x to the half power, I really could have just went ahead and executed. That would be 1/2 x to the negative half. Again, by the power rule. And now the negative sign, that comes from the rules of differentiating trig functions. Just memorize those. You wouldn't want to go through pushing limits every time. Now, or having to dig through textbooks every time. Memorize those. Memorize the derivative of the cosine and the derivative of the sine. Okay? But anyway, now so we got understood negative 1 times the sine of u times a half times x to the negative half. Now guys, that negative 1 just comes in front as a negative sign. The sine of u goes up top. The 2 goes on the bottom. The x to the negative half goes on the bottom as the square root of x. Okay? And now replacing u with what u is, we replace u with the square root of x. We got to go back and replace u. So we put the square root of x in here. And now you can stop here technically, but your professor may want you to rationalize the denominator. Now what I'm going to do is I'm going to yank the 1/2 back out, so I get negative 1/2. You don't have to do that. You can leave the 2 down here if you wish. And but I'm going to go ahead and do it just because it allows me to do something nice is why I'm doing it. And this times sign right here is kind of superficial. You can delete it if you want to. I'm going to keep it here though. But anyway, we got negative 1/2 times. Now, guys, remember the sine of square root of x over square root of x, that's the sinc of the square root of x by the definition of the sinc function, or bad spacing again. Let me move that down. Or negative 1/2 times x radical, my spacing is going berserk on me. I would stop here. I think your professor usually will be more than happy with this. But just to show off that we can do it, you can do negative 1/2 times. You can rationalize this denominator, stick a radical x up here and a radical x down here, and you would get x here. Radical x would just make x itself. X is understood to be positive. And then up here you would have just that radical x times the sign that was already here. Now be careful, this radical x right here, this second one cannot go inside the sign. Remember, the sign is an operator, right? You can't just throw things in there because you feel like it. And of course, the whole time u equals radical x. That's been true the whole time. So now I'll leave it for you to do this guy right here. It proceeds in a similar fashion, okay? And now more chain rule. Now the arc, cosine, these you just have to memorize as well. The inverse trig functions. Remember the arc, cosine. Unfortunately, negative 1 does not mean reciprocal. That is inconsistent. That's unfortunate mathematical notation, but that's just the way they did things. This means inverse function, not reciprocal of the cosine. This is not the secant. This is the arc cosine. So the derivative of the arc cosine of radical x, well, that's the derivative. By the rules of trig, the arc cosine is pi halves minus the arc sine of whatever angle you're doing. Or no, excuse me, the arc sine of whatever argument you're using. This is not an angle, my bad. So the arc, but it is true but anyway, the arc cosine of any number between negative 1 and 1, you do need to be between neg 1 and 1. But I didn't want to go into all that, but it's true. So the arc cosine of, but to be honest, since we're doing the square root, x is just going to be between 0 and positive 1. So for any x between 0 and positive 1, the arc cosine of the square root of x is pi halves minus the arc sine of that square root of x. And for any theta, let's not do theta. For any real number p between -1 and 1 in general, the arc cosine of p is pi halves minus the arc sine of p. But since we're doing the square root of x, we can't allow x to be negative. So arc cosine is pi halves minus the arc sine of that radical x. Okay, now the derivative of this, now the pi halves is going to get killed, but let's go ahead and break it up. So spacing again. So what we get is, let's see. So we do the derivative of pi halves, which is 0, right? That's gone. Minus the derivative of the arc sine. But that's just, this minus sign is just going to stick right here. That's just the negative of the derivative of the arc sine. So now, guys, of radical x. Now we got to do the chain rule, because if this was just x, we could just use the arc sine derivative rule. But we got a square root of x in here. So that's going to be the negative of d by du of the arc sine of u times d by dx of square root of x by the chain rule. Again, this is, we do d by dx of the u term here. Now, we got this negative sign here. Now, here's what happens. Remember d by du of the arc sine of u. You know what? I think I forgot my negative sign, didn't I? I think I surely did. Sorry about that. Did I forget my negatives? I sure did. I'm sorry, guys. I forgot my negative sign there. My apologies. So, now d by du of the arc sine of u, that's 1 over radical 1 minus u squared. And then d by dx of radical x, that's just 1 over 2 radical x. Okay. Now, from comments that we made, remember it's 1/2 x to the negative half power, but that comes down as radical x. So this one, the derivative of the arc sine, you just need to know. I'm not going to prove it, just memorize it. The derivative of the arc sine of x is 1 over radical 1 minus x squared. And if you replace x's with u's, you get 1 over radical 1 minus u squared here. This you just need to know and memorize. You can verify it without too much difficulty, but I don't want to go there, at least not now. Okay. Now, guys, but remember, you got to replace u with what u is. U is the square root of x. So but notice if I throw square root of x here and I square it, I just get x itself. So what I get is well, my negative, forgetting my negative sign means I've probably forgotten it on the other lines here as well. Sorry. So I need to put my negative in here. I'm going to have to annoyingly put it in here. Let me get that over with. I forgot my negative signs. So I got it in there. And then I need to have it in there. So that just gets my negative signs straightened out. Now, guys, so I get this. Now, remember, what I'm going to do is by commutativity on the denominator, I can move my 2 right here, my radical x right here, and my radical 1 minus x here. Remember, the 1 minus x, where did that come from? Well, the 1 minus is easy. The x came from, we threw radical x into u and squared it and just got ordinary x. X is understood to be positive. So here's that ordinary x right here. So now this is correct, but I need to rationalize. So what I'm going to do is I'm going to stick a radical x and another radical x and another radical 1 minus x on the bottom. And to balance that, I'll have to stick them on the top. So here's the radical x, here's the radical 1 minus x. But notice on the bottom, I've got a radical x, I've got 2 radical x's and 2 radical 1 minus x's, and by commutativity and all that, we can, radical x times radical x is just x. By radical, I mean the square root. And radical 1 minus x is just plain 1 minus x. Well, I got to put parentheses around it, though, because I'm multiplying it by 2x, distributive. Okay, you do need these parentheses here. And so I get negative. Now, remember, you can multiply radical a times radical b is the radical of a minus b. So that's going to be, I multiply x distributive, I multiply x times 1 minus x distributive, and I get x minus x squared inside the radical here. And down here, yeah, it's true. Yeah, I could distribute, but I'm not going to bother. Let's just leave it like this. And frankly, we can stop here. Or if you're the kind who likes to write things your way, you know, if you just like to put your own flavor on things, let me skip a line here. If it will let me, it's kind of behaving badly right now. But if you want to write things in your own flavor, what you could do, oops, I misplaced my minus sign. Sorry about that, guys. That should be over here. That would be a messy place to put a minus sign. So if you wanted to put your own flavor on things, you could yank out that negative half and do negative half times this guy over this guy. Okay. Or just radical this over this itself. So there's that. And guys, I'll leave it for you to do this one. And I'll stop the video here. This has been a little demanding. I don't want to overcram. So I'll see you on the next video. Thanks. Bye-bye.